Yes, good morning everybody. So in last class we were discussing about analytical geometry. In that we were discussing basic concepts of analytical geometry. So in that last class we have discussed one formula, that is called distance formula, and also some examples on distance formula. So today we are going to discuss about second formula, that is a section formula in basic concepts. Section formula. So in section formula there are two formulas, one is for internal division and other one is for external division. So in that first I will consider section formula for internal division. Internal division. Internal division means, suppose if you consider any line, that line is divided by the point P, okay, in the corresponding ratio, say m is to n, then you can find the coordinates of point P by using section formula. So here this formula is the coordinates of any point P x comma y, coordinates of any point P x comma y which divides the line joining two points, say A two points A x1 y1 and B x2 y2 is given by coordinates of point P, means that you are going to write P x comma y is equal to, x coordinate is calculated by using the relation, say m x2 plus n x1 divided by m plus n, and for y coordinate m y2 plus n y1 divided by m plus n. So this is called a section formula for internal division. So this formula you are going to prove here today, proof is also there. For that I will consider two coordinate points, say A and B in a plane. So this is x axis and this is y axis. So let A x1 y1 be any point on the plane and B x2 y2 is another point. Consider two coordinate points, say A and B. I will join these two lines, these 2 points A, B. Then we are going to divide this line by a point P in the ratio m is to n, means let P be P x comma y be any point on the line such that it divides the line AB in the ratio m is to n, means this length AP is taken as m and PB is taken as n, that is the ratio m is to n. So here we are going to calculate the coordinates of point P by knowing the coordinates of A and B and also ratio m is to n. So for that I will draw two perpendiculars from these 2 points A and B to the x axis. So draw AL and AM perpendicular to OX, and let P be any point on the line which divides the line AB internal in the ratio m is to n. I will draw one more perpendicular from point P to the x axis like this. So this is n. Further I will draw one perpendicular from point B to the line BM. So it meets at point Q, and also it cuts the line PN at R. So by considering this figure you are going to derive this relation here. Proof. So A x1 y1 B x2 y2 be any two coordinate points on the plane, join AB, draw AL and BM perpendicular to x axis. let p x comma y be any point on the line such that it divides the line AB internally in the ratio m is to n. Draw Pn perpendicular to OX, also draw PQ perpendicular to Bn. It cuts the line Pn at point R. So, in this figure, if you observe this figure, there are two triangles here, and these two are similar triangles. One is APR and other one is ABQ. So, these two are similar triangles. From figure, it is clear that the triangles APR and ABQ are similar triangles. So, then you can consider the ratios as equal, that is I will consider, therefore, can write the equation as AR divided by AQ, AR base of one triangle and base of second triangle AQ, AR divided by AQ is equal to PR divided by BQ, and that is equal to other side, that is AP and AB. So, I will write AP divided by AB. So, since these two are similar triangles, and then you can write this equation. So, I will consider this equation as equation 1. So, in this equation I am going to express these distances in terms of coordinates here. So, for that I will use the figure. See, from figure it is clear that where AR is equal to, in this figure, this distance AR is numerically equal to LM, since we have written perpendiculars. So, AR is equal to LN, can write, and that can be written as LN can be written as ON minus OL, ON minus OL. So, in this figure, this distance ON represents the x coordinate of point P, that is taken as x, and minus OL. OL means this distance, that is the x coordinate of point P, that point A, that is taken as x1. So, AR can be written as x minus x1 in terms of coordinates. Then AQ means this distance AQ is numerically equal to LM, and LM can be written as OM minus OL, So, here in this figure OM means that is the x coordinate of point B, that is taken as x2, and OL is x coordinate of point A, that is x1. So, OM minus OL means x2 minus x1 in terms of coordinates. Similarly, PR distance. So, PR means this distance. This PR can be written as a PN minus RN, and that is equal to PN, okay, minus, instead of RN I will take AL, minus AL. So, in this figure PN means that represents the y coordinate of point P, that is y, minus AL means that is the y coordinate of point A, that is taken as y1. So, y minus y1. Then this distance BQ can be written as BQ means this distance. This can be written as a total distance BM minus QM, and that is equal to BM minus, instead of QM I will write AL. So, BM minus AL. In this figure BM means that is the y coordinate of point B, that is taken as y2, minus AL means y coordinate of point A, that is taken as y1. So, that becomes y2 minus y1. Then this distance AQ from figure, AP is taken as M, then PB is taken as N. Therefore, total distance AB is equal to AP plus PB, that becomes M plus N. So, I have expressed all these distances in terms of coordinates and ratio m is to n. Then from this in equation 1, I will consider the ratio AR divided by AQ is equal to AP divided by AB to derive the x coordinate of point P, this equation. So, consider AR divided by AQ is equal to AP divided by AB from equation 1. So, I will substitute the corresponding coordinates in this equation. AR means x minus x1, that is x minus x1 divided by AQ means x2 minus x1 is equal to AP is equal to m divided by AB means m plus n. Then cross multiply these two and simplifying we get the x coordinate. Cross multiplication means that is x minus x1 into m plus n is equal to m into x2 minus x1, or multiplying by x we can write x into, or first I will write m here, that is m into x plus n into x, then minus x1 minus m into x1 minus n into x1 is equal to m into x2, that is mx2 minus m into x1 is mx1. So, in this minus mx1 and minus mx1 can be cancelled from left hand side and right hand side. Remaining is in this I will take out x common factor, then you get m plus n is equal to, I will transfer this mx2 minus nx1 transferring to right hand side, we get plus nx1, mx2 plus nx1. Therefore, x is equal to, you can write x is equal to mx2 plus nx1 divided by m plus n. So, that gives the x coordinate of point P, that is x is equal to mx2 plus nx1 divided by m plus n is the x coordinate of point P. Similarly, by considering the equation PR divided by BQ is equal to AP divided by AB, we can derive the y coordinate of point P, and that is given by, the expression for y coordinate is given by y is equal to my2 plus ny1 divided by m plus n is the y coordinate of point P. So, that is the proof of this equation. So, totally put together you can write P x comma y is equal to mx2 plus nx1 divided by m plus n comma my2 plus ny1 divided by m plus n. So, that is the section formula. It is used to find the coordinate of point P x comma y, which divides the line AB internally in the ratio m is to n. So, this is section formula for internal division. This is first equation. Similarly, there is another formula, that is for external division, second one. So, this is the proof, proof of section formula. So, afterwards I will take a section formula for external division. Section formula for external division. external division. External division means suppose if you consider any two coordinate points, say a x1 y1 and b x2 y2 are the two coordinate points. So, if you join these 2 points, line AB, suppose if this line AB is divided by the point P externally like this, this is point P whose coordinates are x comma y. So, in this case point P divides the line AB externally in the ratio m is to n. So, here m means this distance AP is taken as m ratio, and PB that you are going to measure in reverse direction, that is n. So, for this equation can be directly written by substituting n is equal to minus n in internal division formula. So, internal division we know p x comma y is equal to mx2 plus nx1 divided by m plus n and my2 plus ny1 divided by m plus n. So, in this I am going to put n is equal to minus n, then we get the formula for external division. Therefore, the coordinates of any point p x comma y which divides the line joining 2 points a x1 y1 and b x2 y2 externally in the ratio m is to n is given by p x comma y is equal to m x2. So, here plus is there, for that we are going to substitute n is equal to minus n, that becomes minus m x2 minus n x1 divided by m plus n, then m y2 minus n y1 divided by m minus n, here also it is minus, n is equal to minus n. So, we get m minus n. So, this equation is called a section formula for external division. So, for this equation proof is not required, just you have to remember this equation. So, in internal division formula only, suppose if you substitute n is equal to minus n, then we get the formula for external division, that is given by p x comma y is equal to m x2 minus n x1 divided by m minus n and m y2 minus n y1 divided by m minus n. So, this is the section formula for external division. So, then this is second equation. Similarly, we are going to write one more equation here, that equation is called the midpoint formula. Midpoint formula. Midpoint formula means suppose if you consider line joining 2 points, say one is a x1 y1 and b x2 y2. So, this line is divided by the point P internally, and that point is the midpoint of line AB. So, if P is the midpoint of this line AB, then these two distance AP should be equal to PB. That is here we are going to take this ratio as m is to n. So, in this suppose if m is equal to n, these two distance m is equal to n, then P is the midpoint. P is the midpoint of line AB. Then the coordinates of this point P x comma y can be written as a midpoint formula is the coordinates of midpoint P x comma y of line joining 2 points a x1 y1 and b x2 y2 is given by P x comma y is equal to midpoint formula, that is x coordinate is given by x1 plus x2 divided by 2 and y coordinate is given by y1 plus y2 divided by 2. So, this equation is called midpoint formula. This you can obtain by using the section formula internal division. In this suppose if you substitute m is equal to n in the section formula, then we get this relation. This is called midpoint formula, that is p x comma y is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So, by substituting the coordinates of points A and B in this equation, you can find the coordinates of midpoint P by using this relation. That equation is called midpoint formula. So, here we get 3 relations. One is a section formula for internal division, second one is a section formula for external division, and third one is a midpoint formula. So, after this in this chapter there are 2 more relations. that is related to triangle. One is centroid of a triangle and other one is area of a triangle. So, by knowing the coordinate points of vertices of the triangle, you can find the coordinates of centroid G and also area of a triangle. So, in that first I will consider centroid. Centroid of a triangle ABC. Centroid means, see, suppose if you consider one triangle ABC, so A x1 y1, B x2 y2 and C x3 y3 are the vertices of the triangle ABC. Then the centroid of this triangle means, I am going to write one median from point A to the opposite side BC. Median means, if you identify the midpoint of side BC, suppose if D is the midpoint of the line BC, then if you join these 2 points, that is A and D, then this is called median. AD is the median of the medium drawn from point A. Similarly, if you draw medium from point B to the side AC, so in this I will consider E is the midpoint of line AC, then if join BE, this is also median. Similarly, I will draw one more medium from point C to the line AB. In this, suppose if F is the midpoint of line AB, then join these 2 points, that is F and C, like this. So, all the medians intersect at a point and that point is called centroid, that is represented as G, centroid of the triangle. So, in this always centroid of a triangle G divides the medians in the ratio 2:1. That is, the median AD is divided by this point G in the ratio 2:1. Similarly, median BE is also divided in the ratio 2:1 and CF is also divided in the ratio 2:1. So, this point of intersection of the medians is called a centroid of a triangle. So, by knowing the coordinates of these 3 vertices points A, B, C, you can find the coordinates of centroid G. Okay. So, for that there is one formula, that is called centroid of a triangle. Here the coordinates of centroid G x comma y of a triangle ABC, whose vertices points are A x1 y1, B x2 y2 and C x3 y3 is given by G x comma y is equal to x coordinate is given by x1 plus x2 plus x3 divided by 3 and y coordinate is given by y1 plus y2 plus y3 divided by 3. So, this equation is called a centroid of a triangle, coordinates of the centroid of a triangle, that is given by G x comma y is equal to x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3 divided by 3. So, this formula you can derive by using once again section formula, since this median AD is divided by the point G internally in the ratio 2:1. So, after this here, by knowing the coordinates of the vertices points of a triangle, you can also find the area of a triangle. So, for area of a triangle is given by area of a triangle ABC, that you are going to represent it as a delta, area of a triangle. So, the formula for area of a triangle is given by area of a triangle delta is equal to half into, this you can write in the form of determinant form, half into determinant of, in the first row you are going to write the x coordinates of the vertices points A, B, C, that is x1, x2, x3 that you have to write in the first row of the determinant, and in second row you are going to write the y coordinates, that is y1, y2 and y3, and in third row just you have to write 1, 1, 1. So, this gives the expression for area of a triangle. So, by substituting the coordinates of vertices points A, B, C in this equation and expanding this determinant, you get the area of a triangle. So, suppose area of a triangle, you get the negative sign, that you have to neglect, since area of a triangle is always positive here. So, delta, area of a triangle delta is equal to half into determinant of x1, x2, x3, y1, y2, y3, 1, 1, 1, or by expanding this determinant you get another relation for area of a triangle, that is given by delta is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So, both are same area of a triangle, you can use any relation, but this is better to remember, that is delta is equal to half into determinant of x1, x2, x3, y1, y2, y3, 1, 1, 1, or another formula is area of a triangle delta is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. That is, by expanding this determinant you get this equation. So, this equation is called area of a triangle. So, related to triangle, that is, by knowing the vertices points A, B, C, you can find the centroid of a triangle and also area of a triangle by using these two equations. So, totally today you have discussed total 5 equations. One is a section formula for internal division, second one is a section formula for external division, third one is a midpoint formula, then fourth one is a centroid of a triangle, and last one is area of a triangle. So, now we are going to discuss some examples on these equations. So, we are going to solve some problems on these equations, examples. So, in that first one, first problem, find the coordinates of a point, find the coordinates of a point which divides the line joining 2 points, 1, 3 and 4, 9, line joining 2 points 1, 3 and 4, 9 internally and externally, in the ratio 5:3, in the ratio 5:3. So, here the problem is find the coordinates of the point which divides the line joining 2 points 1, 3 and 4, 9 internally and externally in the ratio 5:3. So, both you have to find the coordinates for internal division as well as external division. So, here first I will consider the given points as let A 1, 3 and B 4, 9 are the given points, are the given 2 points, and P x, y is the point of division. Okay. So, with this point divides line joining these 2 points A, B internally and externally in the ratio 5:3. So, ratio means you are going to consider this ratio as m:n here. That means m value is 5 and n value is 3 here ratio, and the coordinates of these 2 points is taken as first point coordinate is x1, y1 and that of second point is x2, y2. So, first I will consider for internal division. for internal division. For internal division, we know the section formula for internal division, that is the coordinates of any point p x comma y which divides the line joining two points a x1 y1 b x2 y2. Internally in the ratio is m is to n is given by p x comma y is equal to m x2 plus n x1 divided by m plus n, that is x coordinate, and m y2 plus n y1 divided by m plus n, this is for y coordinate. So, this is section formula for internal division. So, in this you are going to substitute the coordinates of these two points a, b, and also ratio m is to n. So, substituting in this we get m x2, m value is 5 here, into x2 means x coordinate of second point b, that is 4, plus n x1, n value is 3, into x1 is 1 divided by m plus n means 5 plus 3, this is x coordinate, comma y coordinate m y2, m is 5 into y2 is 9 plus n is 3 into y1 is 1 divided by m plus, sorry, y1 is 3 here, divided by m plus n, that is 5 plus 3. So, by solving this we get the coordinates of point P, that is given by 5 into 4 20 plus 3 divided by 8, and y coordinate 5 into 9 45 plus 3 into 3 9 divided by 8, or you can write this as 20 plus 3 23 divided by 8, 45 plus 9 is 54 divided by 8, and 54 by 8, this is divided by divisible by 2, by dividing by 2 you get 27 divided by 4. Therefore, the coordinates of point P x comma y is equal to x coordinate is 23 by 7, 23 by 8, and y coordinate is 27 by 4. So, these two are the coordinates of point P. This is for internal division. Similarly, you can calculate the coordinates of point P for external division also. For external division means just you have to consider negative sign in between in this formula. So, for external division, I will write in this side. For external division, equation is p x comma y is equal to m x2 minus n x1 divided by m minus n, and y coordinate is m y2 minus n y1 divided by m minus n. So, substituting in this we get p x comma y is equal to, same coordinates are same, 5 into 4, m value is 5 into 4 minus 3 into 1 divided by 5 minus 3. Then for y coordinate is 5 into 9 minus 3 into 3 divided by 5 minus 3. So, by simplifying this we get 20 minus 3 divided by 5 minus 3 is 2, then 45 minus 9 divided by 2, or you can write this as 20 minus 3 is 17 divided by 2, 45 minus 9 is 36 divided by 2. So, dividing by 2 you can write p x comma y is equal to 17 by 2, 36 by 2 is 18. So, that is the coordinates of point P for external division. Okay. So, here we have solved problem on both the relation, that is for internal division and external division. So, coordinates of point P for internal division is 23 by 8 and 27 by 4, and for the external division we get P x comma y is equal to 17 by 2 and 18. So, this is the first problem on section formula. So, after this we will consider another problem. Second one. Find the coordinates of the points of a trisection of the line joining two points. Find the coordinates of points of trisection. Points of trisection. Find the coordinates of points of trisection of the line joining two points. Points of trisection of the line joining two points. One is 6 comma 8 and other one is minus 2 comma plus 2. So, here you have to find the coordinates of points of trisection. For this ratio is not given, that you have to consider here points of trisection. So, for that we will consider the given points are A and B. Let A 6 comma 8 and B minus 2 comma 2 are the given points. So, in this suppose this is line AB, A B, line joining two points. So, if this line is divided by 3 parts, points of trisection means you have to divide this line by 3 parts, equal parts, that is this I will consider 2 points here. This is one part, this is second part and this is third part. Like this we are going to divide this line as 3 parts by 2 points. So, one is P and other one is Q. So, here this P divides the line AB internally in the ratio out of 3 parts. This distance is 1 and this distance is 2 parts. So, this point P divides the line AB internally in the ratio 1:2. Similarly, point Q divides the line AB internally in the ratio 2:1. Therefore, these 2 points are called points of trisection of this line AB. So, you have to find the coordinates of points of trisection means you have to find both the coordinates of point P as well as point Q here. So, for that once again we are going to use section formula for internal division. So, first to find the coordinates of point P you have to consider the ratio as 1:2, and similarly for the point Q you have to consider the ratio as 2:1. The coordinates of point P, point A is taken as x1 y1 here, and that of point B is x2 y2. So, here first I will find the coordinates of point P. Point P x comma y divides the line AB, internally in the ratio 1:2, internally in the ratio 1:2. So, that ratio is taken as m:n here. Therefore, the coordinates of point P x comma y is given by according to section formula for internal division, that is mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n. So, substituting in this formula, value of m is 1 here, into x2 is minus 2 plus n is 2 into x1 is 6 divided by m plus n, 1 plus 2, comma y coordinate m y2, m is 1 into y2 is 2 plus n is 2 into y1 is 8 divided by m plus n, 1 plus 2. So, by simplifying this, we get the coordinates of point P, that is 1 into minus 2 is minus 2 plus 2 into 6 is 12 divided by 3. Here 1 into 2 is 2 plus 2 into 8 is 16 divided by 3. Or you can write this as minus 2 plus 12 is plus 10 divided by 3. Here 2 plus 16 is 18 divided by 3, or it can be written as 10 by 3 comma 18 by 3 is 6. So, 10 by 3 comma 6 is the coordinates of point P. So, here P is the point of trisection of the line AB. Similarly, we are going to calculate the coordinates of point Q also, that is also point of trisection, but here you have to consider this ratio as a 2:1 for point Q. So, I will write in this side, say point Q divides the line AB, internally in the ratio 2:1, internally in the ratio 2:1, that is here m value is 2 and n value is 1. Therefore, the points of coordinates of point Q x comma y is given by, once again by using the same section formula, m x2, m is 2 here, into x2 means minus 2 plus n x1, n is 1 into x1 is 6 divided by m plus n, that is 2 plus 1, and y coordinate m y2, m is 2 into y2 is 2 plus n y1, n is 1 into y1 is 8 divided by m plus n, that is 2 plus 1. So, by simplifying this, we get 2 into minus 2 is minus 4 plus 1 into 6 is 6 divided by 2 plus 1 is 3. Here 2 into 2 is 4 plus 1 into 8 is 8 divided by 2 plus 1 is 3, or you can write this as minus 4 plus 6 is plus 2 divided by 3, 4 plus 8 is 12 divided by 3. Therefore, the coordinates of point Q is 2 by 3 comma 4. So, that is the coordinates of point Q. Like this, you can find the coordinates of points of trisection of the line joining two points, that is P and Q. So, in case of points of trisection, ratio will not be given, that you have to consider. For one point you have to consider ratio 1:2, and for other point that is 2:1. So, next problem, third one, find the ratio in which the point minus 10 comma minus 1 divides the line joining two points minus 2 comma 3 and minus 6 comma 1. So, find the ratio in which the point minus 10 comma minus 1 divides the line joining 2 points minus 2 comma 3 and minus 6 comma 1. So, here the coordinates of point of division is given, point of division is p x comma y is given, and the coordinates of 2 points is given, but ratio is not given, that you have to find out here in what ratio this point is going to divide this line. So, for that let a minus 2 comma 3 and b minus 6 comma 1 are the line joining 2 points, and p minus 10 comma minus 1 is the point of division, So, that means the coordinates of these 2 points is taken as x1 y1 here and x2 y2. Coordinates of point P is x comma y. So, to find the ratio of division, you have to consider the section formula only, that is for internal division. That formula we know, that is P x comma y is equal to section formula for internal division m x2 plus n x1 divided by m plus n, m y2 plus n y1 divided by m plus n. So, in this I will substitute the coordinates of point P as minus 10 comma minus 1 is equal to, m value is not given. So, I will write m only, into x2 is minus 6 plus n into x1 is minus 2 divided by m plus n, m y2, m into y2 is 1 plus n y1, y1 is 3 divided by m plus n. So, here we can equate x coordinate like this or y coordinate like this. So, by equating any one coordinate x or y coordinate, we can find the ratio of division m is to n here. So, for that I will consider x coordinate only. So, here minus 10 x coordinate should be equal to x coordinate of this point is minus 6 m minus 2 n divided by m plus n. So, by cross multiplying we can write minus 10 into m plus n is equal to minus 6 m minus 2 n, or multiplying by minus 10 you can write minus 10 m minus 10 n is equal to minus 6 m minus 2 n, or I will write this as minus 10 m minus 6 m, by taking to left hand side that becomes plus 6 m is equal to minus 10 n becomes plus 10 n on right hand side minus 2 n, or minus 10 m plus 6 m is minus 4 m is equal to 10 n minus 2 n is 8 n. So, we need the ratio m is to n, means you can write m divided by n is equal to 8 divided by minus 4, or you can write this as minus 2 by 1. So, therefore, m by n is equal to minus 2 by m here, that implies m is to n ratio, m is to n is 2 is to 1. Here negative sign indicates that this point divides the line AB externally. Suppose if you get the ratio as positive, then that means it is internal division. If you get ratio as negative value, then that means that that point divides the line AB externally here. So, therefore, here you can write a point point minus 10 comma minus 1 divides the line joining 2 points externally in the ratio 2:1, externally in the ratio 2:1. So, like this you can find the ratio of division also by using section formula here. Two is to 1. So, after this I will consider one more problem. Next one. Find the ratio in which the point 2, 3 divides the line joining 2 points minus 1, 0 and 4, 5, minus 1, 0 and 4, 5. So, here to solve this problem also we are going to use same section formula only. Let A minus 1, 0 and B 4, 5 are the line joining 2 points, and P 2, 3 is the point of division. So, here the coordinates of point A and B is taken as x1, y1, x2, y2, and the coordinates of point P is x, y. So, we know that according to section formula for internal division, that is P x, y is equal to m x2 plus n x1 divided by m plus n, comma m y2 plus n y1 divided by m plus n. So, in this I will substitute the coordinates of the points. P x, y is 2, 3 is equal to m x2, x2 is 4 here. So, m into 4 plus n x1, x1 is minus 1 divided by m plus n. Similarly, m y2, y2 is 5 here plus n y1 is 0 divided by m plus n. So, here also you can equate the coordinate x coordinate to x1 and y coordinate to y coordinate of the right hand side. So, in this problem I will equate y coordinates like this of the points. So, here the y coordinate is in the left hand side is 3 is equal to, in right hand side this equation is 5m plus n into 0 is 0 divided by m plus n. So, by simplifying this cross multiplying we get 3 into m plus n is equal to 5m, or multiplying by 3 you can write 3m plus 3n is equal to 5m. So, I will transfer this 3m to right hand side, then you can write 3n is equal to 5m minus 3m, that becomes 2m. Therefore, 3n is equal to 2m. We need the ratio m by n, therefore, you can write m by n is equal to, that becomes 3 by 2 ratio, or you can write ratio m is to n, m is to n is equal to 3 is to 2. So, that is the ratio of division. Here this ratio we get positive value, that means that this point divides the line joining 2 points internally in the ratio 3 is to 2. Suppose this ratio is negative, that means that that point divides externally. So, in this case it is internal division, since this ratio is positive here. So, that is about some problems or examples on section formula. So, today we have discussed some examples on section formula, and in next class I am going to solve some problems on midpoint formula, then centroid of a triangle and also area of a triangle. So, that I will take up in the next class. Okay, thank you.